Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 33, Physics Class Design. In the previous video, we talked about some of the theory behind physics and what's going to go into our simulation of physics in order to improve the video games that we'll be creating. Before we dive into the coding itself, it'll be good to think about what we need to put into the class. So in this video, we'll talk about that. So within the physics class, some of the obvious information it will need to store will be position, velocity, and acceleration. Now, we want the physics class to be self-contained. And you might wonder, well, why do we need to store the position? The position, well, that's also going to be stored in the sprite class. Eventually, once we incorporate the physics class into our game framework, what we'll do is whenever we're about to apply physics, we'll copy over position data from our sprite into the physics class. We'll have it do its calculations, and then the physics class will tell us what the new position of the sprite should be. Right, so we do want the physics class to be self-contained. That's why it will also store position in addition to velocity and acceleration vectors. Also, to make calculations a little bit easier, we're going to store an acceleration value, and we'll often use that to say when we move our sprite in a certain direction, we'll create an acceleration vector based on this base value. We'll also have a maximum speed, so our sprites don't go too fast, so they don't make it up to glitch speed. And we'll have some kind of a deceleration value, which tells us how quickly our objects will slow down. And in those values, we'll say they'll be set by the constructor of the class. Some other useful things we'll use a get speed and set speed method, right? And those are just getting and setting the length of the velocity vectors. We'll have a get motion angle and set motion angle function. And again, that's just getting and setting the angle of the velocity vector. We'll also have an accelerate by function. And that will basically create an acceleration vector of this length and this acceleration angle. And we'll use this sometimes. But if you have stored the correct acceleration value, more often we'll use this function, accelerate at angle, and we'll only need to change the angle. The accelerate by function, we'll write that for convenience. That would be more useful if you could accelerate at different speeds. Finally, we're going to need an update function, right? That will calculate the new position, taking all these different things into consideration. And it does require us to know how much time has elapsed in our game. Typically, our games will run at 60 frames per second. The animation timer class that we use in Java FX will try to run that function 60 times every second. So we could try to calculate this precisely, but for a first pass, we'll often set this to be 1/60th of a second. So that's what we're going to need in the physics class. And next, we need to turn our attention to writing the code. So we'll do that in the next video. Thanks for watching.